Hello, and welcome to your mini lecture on nuclear rates, fission, and fusion from our Chemistry 1412 class. Nuclei follow the first order integrated rate law. We will look more closely at half-lives of radioactive substances. Then, we will take a look at both splitting and combining nuclei. Both have the effect of releasing a tremendous amount of energy. This is the first order half-life. It is a review from our earlier discussion of kinetics. Remember that half-life is equal to the natural log of 2 divided by the rate constant k. In terms of radioactivity, the shorter the half-life of a radionuclide, the hotter or more intense it is. The energy of nuclear reactions is huge. 1 gram of glucose gives 15.6 kilojoules of energy when combusted. 1 gram of helium gives 400 million kilojoules of energy when made via fusion. It is quite clear that nuclear energy vastly outperforms fossil fuel energy. The energy of nuclear reactions comes from something called binding energy or mass defect. You can calculate this energy by obtaining the mass of a nucleus and the mass of the sum of the nucleons in that nucleus. The difference between the nucleus mass and the sum of its parts is the binding energy. The mass values are small, but when converted to energy via Einstein's equation of relativity, become huge. The waste from energy production using fossil fuels is much larger in quantity than the amount of waste generated by nuclear power. 1 kilogram of coal generates 300,000 tons of radioactive waste. 1 kilogram of uranium-235 produces 20 tons of radioactive waste. In terms of both energy output and waste produced, nuclear energy is the clear choice. But, like other powerful resources, nuclear energy presents us with great technical challenges and hazards. Nuclear power plant accidents have tremendous consequences for the plant workers and the people who live in the region of the nuclear power plant. Accidents at nuclear reactors have huge repercussions. This is the accident in 2011 at the Fukushima power plant in Japan. The plant had been built to withstand vibration from earthquakes, but it was not prepared to withstand damage from a tsunami. The reactors which failed at this plant will cause the area to be inhabitable for many centuries to come. In 1986, the nuclear reactor in Chernobyl, USSR, experienced a catastrophic meltdown. The meltdown was caused by negligence of managerial staff. The site of the meltdown remains extremely radioactive and will for thousands of years. This accident and all of the other accidents in the nuclear industry prove that great care and highly disciplined management of nuclear reactors is imperative if we are to safely harness the energy from nuclear reactions. Very heavy nuclei become unstable, and then they become elongated. They form a saddle point and then cleave to become 2 large chunks while also emitting several neutrons. These neutrons are absorbed by other heavy nuclei which are adjacent, and then they also split, releasing neutrons which go on to initiate more reactions. This is called a chain reaction. If too much fissile material is put in one chunk, critical mass may be achieved, which leads to terrible things. Nuclear reactors differ in fuel and design, but they all have some key aspects in common. The core of reactors is housed in a closed system of water, which becomes heated near the core and then turns to steam, which is used in generators to create power. The water from which steam is made is isolated from the water in the core. The water in the core is meant to stay in the core system. Any leak will cause danger to the surrounding plants and wildlife. After being used to generate power, the water from the steam generation system is cooled, usually using a large body of water nearby, and then reused as it is warmed again by the water from the core system. Moderation and even shutdown of the nuclear core is governed by control rods, usually made of boron-containing substances. Boron is a neutron sponge and will soak up the neutrons given off by the fission of the fuel, removing the possibility of a chain reaction occurring. Complete removal of the control rods for sustained periods of time could result in a core meltdown. Nucleosynthesis is the creation of a nucleus by way of fusion. It occurs in the interior of stars as well as in research facility particle accelerators and colliders. All elements larger than hydrogen and helium were created inside a star, save the ones created here on Earth by scientists. Nuclear physicists have created more than 2,200 different new nuclides. These nuclides have extremely short half-lives and do not exist for very long at all. This has been your Chemistry 1412 lecture on nuclear fission and fusion. Please go to your homework website and complete the associated assignments at this time. If you run into confusion, please reach out for help. Help is always available.